With the simple stuff. Let's start with the stuff that I've avoided showing you, which is how to read from standard input. Now, one of the tricks that's happened in Java is that since it's been around for, 15 years now, they're now on about version 3 or 4 of most of things like file utilities. And so you can go see source code from 15 years ago that uses things that you've never seen before versus there was some standard stuff that was used in Java 1.6, used an awful lot, and then all of a sudden they came along and they said, let's just make things a little bit easier and have yet another version of the file stuff. So I think in total now I've seen like 3 or 4 or 5 ways of doing things in the past 15 years, right, that all get a little better. It just means that when you're reading Java source code, it's tough to figure out what's the latest. Okay. So let's look at the latest way for doing something like just reading input. So I'm going to make a files driver thing here, and we'll just try out some things. Put a main program in. Let's do the simplest and newest way of doing user input. So we'll print something out. The thing that does user input the easiest way is that there's a beast called the scanner class. And for the scanner class, you give it a name and you make a new scanner object. And you tell it to read from system input, which is this variable called system.in. And we'll do the import statement. And then we'll just try reading one line. We'll use next line. We'll worry about the other ones later. And print out whatever we happen to say. Okay. In the old days, reading user input was actually way more complicated than this, and so the scanner class simplifies it and hides a whole bunch of stuff that you really don't need to see, other than that you have to know to supply the scanner class with where to get the input from, which that just means the console. And we'll run the thing, and we'll enter some input if I go into the right place. So there's my input, and it grabbed the line of text. Okay, right down at the bottom there. Okay, so that's all there is to it for reading user input. Now let's make our lives a little more interesting. If you look at that scanner class, and I just type scanner dot, or sorry, result dot, and just see what sorts of things it can do. Turns out that, as with all sort of Java objects, it seems this one does all sorts of interesting stuff, including apparently searching for strings using index of. Split starts with substrings, all sorts of goodies, converts things to uppercase, and a whole bunch of other stuff. Okay, so it's a fairly complicated beastie, but one of the things that the scanner class does is that it emulates what you would do with an iterator. So guess what? it has a has next and a next. And so we've actually used one of the variations of next. Okay? So if you wanted to keep getting user input, you would do something like, say, while input dot has next is actually, let's not do it that way. I'm going to change it. I'm going to just change this around and do it a slightly different way. I'm going to say string input or result is starts out as nothing, and I'm just going to flip this around a little bit and turn it into a more traditional while loop. Lower letters. Done like that. I've got to get rid of that middle mouse key, I think. Run source format on it just to make it pretty. So there's sort of a traditional idea of, I'll start out with my string as being something other than done, and then for as long as they don't type done, I'll print out, I'll read some input and then print it out. So let's give that a try and see what happens. So now enter input. I can enter some stuff, enter some more stuff, enter some more stuff, and if I ever type done, then it says done and didn't exit the program, or did it? Yeah, terminated. Little terminated word there, so that finished the program. Okay, so there's a traditional sort of way of reading user input until they say something, and then turning around and just printing it out. So you could do whatever you wanted there. Okay, so that's one use for the scanner class. Let's try a different use for the scanner class. And we'll just make sure that we get the URL class imported. Sorry, missed one thing here. That should make it a little bit happier. So I won't worry too much about that. What else am I missing? See what my little bulb says. I think that's right. It just doesn't like my... I think that little red underscore is an artifact from the looks of things. I don't think it's generating an actual error message. We'll just give it a try. I spelled Camosun correctly. So just out of interest's sake, let's do a same thing we did before. We'll read one line. Get that right. sorry, next line. Capital L line. And we'll print that one line out and just see what it says. And I'm just going to leave this code in here so that you can use it later, but I'm going to do the thing I always advise you against doing, and I'm going to just comment it out. Sorry. Okay, so just get down to those 3 lines. Let's just run it and see what happens. See if I got this right. Does that look familiar? Well, just for fun, let's do the same thing that we did with reading from standard input. Let's just use the feature. This time I'm going to use the while Camosun dot has next. And someplace in all these has nexts, there will be a has next line. And I'm just going to encase that inside a loop. Like so. Okay? So instead of reading one line, I'm going to keep reading all of them as long as there's a line to read. Okay? And we'll save that, and we'll run that thing. And just move this up a little bit so that you can see it, starting from maybe the top. Does that look familiar? So there's all of the HTML for Camosun's main web page. Okay? So if you wanted to process it in any way, for instance, if you were trying to search for something in Camosun's web page by doing some sort of screen scraping, you could just come along and replace that printout with anything you want to try and find the thing that you're looking for. Okay? So do whatever processing you want on it now that you can read the whole web page. Okay? So there's you now have the trick to not only read from standard input, but you can also use that scanner class now to turn around and get input from any place off the web. Same sort of style. Any file that a web server can serve that's text-based, there's your opportunity to go get it. Okay, questions about that? Seem fairly reasonable so far? Okay. Let's try something else with the scanner class. And again, I'm going to comment out that bit of code just so I don't have to start a new file. Let's try something different. Arguments on a command line. Something like oops, I better not use that. So here's sort of a standard thing that you would do. This could be on something like Linux, where you issue a command and then you say something equals some value, or it's when you get stuff from a web server, it's name value pairs, any of that sort of game. And so you've got this big long command line with what's essentially name equals value stuff. Okay? And what I'd like to do is split that up into name and a value inside my program, get rid of the equal sign, find the next pair of things, split it up into a word and a value, that sort of stuff. Okay? Well, turns out that the scanner class not only takes read from user input or read from a URL, but the other option that you can give the scanner class is you can make a new scanner. and feed it a string. Oh, I can't use args, sorry. Do something like that. Okay, so scanner accepts a string. And so now I can say while line scan dot as next, and we'll just call this something and see what happens for now. Go grab the next line, and we'll print that out. And see what happens. Name equals Fred, social insurance number. It didn't split them up, which isn't quite what I want. Just go find my line splitter beastie. Oh, yeah, this reads a line at a time, so there's just one line. Instead of a line at a time, let's do line scan dot just next and see what happens. So next line reads a line at a time, but the next function reads through the string until it finds a space, and then it stops. Okay? And so what I've managed to do is I've managed to read the space in there, grab that first thing, and then the social insurance number next, and split those up. Okay? So I'm sort of half done here. If I actually want to get rid of the equal sign, it looks like what I'm going to have to do is somehow split this thing up into what's on one side of the equals versus on the other side. Okay, just to get it totally split up. So what I'm going to do here is I'm just going to replace this with another thing that says, we'll call it split line or split word. Split word on equals, and I'm going to give it that string. So I'm just going to write a little subroutine here just for the pure fun of it. And I have to use static because it's in a main program. Normally I wouldn't. So now the issue becomes, given a string which says something like name equals value, how do I split that thing up? I could use a regular expression, and I'm sort of kind of going to use something that's not quite a regular expression. Scanner has this facility built in again, so I'm going to make yet another scanner. And just like I did in the sort of the loop there, just before the loop, I'm going to now pass that other string with name equals value into the scanner thing. But now scanner has this option to say use delimiter. Oh, notice it has a couple of options for use delimiter. The one I'm going to use is say use delimiter, and I'm going to give it a string, and I'm going to say I want you to use now an equal sign instead of a space as the thing that's going to be used to split and give me the next thing. Okay. And now you can say, since I know there's should only be two things on the line, I'm not even going to write a while loop here. I'm going to say string first word is scan.next, and string second word is call another scan.next. And we'll just print those out. Some amount of text. Just to show you that I managed to get them split without the space in them. Okay, so no while loop there because I'm only expecting to have two things on a line separated by an equal. I'll not bother using the iterator ID. I'll just grab each piece individually. Okay, so this thing would break if there was some sort of malformed expression, but at this point I'm not worried about it. And run it again, and I've now managed to have name and Fred and social insurance number and the number with some sort of weird text between them. Maybe put that in there just so that there's not so much gunk in there. Okay, so the bottom line of this whole exercise is really that Scanner is your friend. Scanner is useful for reading from standard input. It's useful for reading stuff from across the web if you want to do that. And it's also useful as a sort of a quick string manipulation tool when you want to parse arguments and split things based on some sort of delimiter. And it has that feature in it of an iterator. While has next, go get me the next thing, go get me the next thing, and keep processing until there's nothing left. Okay, and so in the first case I didn't make use of the has next. What I did was I just used the idea of taking an actual of using user input with some sort of token. Okay, so that's why there's no has next there. But in the second case, where I now all of a sudden know that the file has to end on an end of file, I use the has next line function to just keep saying there's something, there's something, there's something until there's nothing there anymore. Okay, so those are sort of your two options. And it also shows the idea that even if you have something that looks like an iterator, you can still turn around and call it out, just go get me a thing, go get me a thing. As long as you know it's there, it won't blow up on you. Okay, so didn't need a loop to do that. Okay, so three uses for the scanner function, all little nice handy utilities. Okay, that was scanner. Let's try something else. Suppose that we want to do something with an object instead. So we'll do something like, we'll make a student object. I'm just going to start a new driver here. Leave that one alone. Put another new main program in. Put this into my files class. And say finish. So what I've done in my class is I've also made just a simple student class here that we can use as a test, because now we've got the idea that someplace along the line I've got a main program that's got a bunch of students in it, and I want to turn around and write out all of that information to a file. Okay? So we'll start out with the the simplest form of doing stuff, which is figuring out how to write out the student stuff to a text file. Okay, at least it's reasonably readable for people. So I'm just going to go grab some student stuff I have lying around so you don't have to see me type so much. So we'll make an array list, and we'll drop a bunch of students into it. Okay, so there's my list of students, and now your program is ending. It's time to save your data to a file. It's been running for a while. The question is how do we go through that list and add all of the students out to a file someplace? So let's start with one student, and then we'll figure out how to do it for more than one. So we'll go get the 0 position out of the list, who's Fred, and we'll figure out how to do something with him. Okay. Last year, they introduced yet another new way of doing stuff with reading and writing to files. And so I'm going to use basically the latest and greatest thing that's so new that I don't even have it memorized. So I'm going to go steal my samples here and see if I can show you line by line how to do it. So let's start out with the path thing. The path object is something that just gives you a standard path name. And the path object is sort of smart enough that it knows how to interpret Windows paths versus URL paths versus Apple paths versus Linux paths. Okay, depending on what system it's running on, it knows basically how to interpret everything. Right? And notice that the paths variable is going to be used in the sense of I need to do something with a file. So it's really going to be in its easiest format, a file name. Okay. So in order to use it, there's a couple of things that we have to do. We have to define a file name. So let's call it something, we'll use the Windows-ish thing of saying it's a text file. Okay. And the other thing that we're going to have to do then is we've got our paths beastie set up. I thought I did that import. There we go. And so what happens if you want to read or write to a file is you have the file name string or path. That could be C:, whatever, but I'm just going to write it out to the current directory. And then you supply that to the paths beastie to say, I want to do something with this thing. So that basically means in other language, open the file. Okay. Now, I'm just going to try to see if I can do this one line at a time and then add some stuff around it. The way that you would try to read from a file is you would make this thing that Java calls a buffered. Actually, we're going to try to write to a file, aren't we? Where did I put that? We're going to have to make a new buffered writer object. And we'll give buffered writer the file name, which is that. And the other thing that we have to give it, unfortunately, is another parameter which tells it the character set you want to use, because we're an international organization now. And so we'll say we want to write out our stuff in just plain ASCII. So you can use that to write it out in different character sets, international character sets, and you supply the character set as the second parameter on the thing that you want to write out. Do another import statement for buffered writer, and we'll just leave that one alone for a second. Oh, I know why. Okay. So in its essence, that would open up the file, and I'm just going to show you the one line for writing one thing out. Let's just do it this way. String first is talk to who.getFirstName. I'm just going to grab the strings out of the object so I can see them a little easier. What's the other one? Oh, that's enough for now. So there's go grab the first name and last name, and then we'll turn around and we'll form one big string with them. I guess I could have used two string. So basically what I'm doing is I'm converting the object into a string, in this case not using the toString. And then to write it out, you would talk to the writer object and surprisingly say writer.write, and you would give it the string that you want to write, which is result. And writer doesn't write a new line by default. But it does have a method that will do that for you. Why do you think it's a method rather than writing out a \n? Just out of interest's sake.
Because all the different standards?
Because, yeah, depending on what computer you're on, it might be a \n for Linuxy type stuff, but Windows doesn't use \n. Windows uses something else. Some weird, I think it's a \r or carriage return or whatever, but there's different standards, right? And so by making that thing into a method, it allows the writer to figure out what kind of computer am I running on and write it out in the appropriate format. Okay, so that's why there's no actual constant that you would use. You wouldn't actually say the \n there. Okay. Now the only problem we have here is that it's unhappy with this line, and now here's where the goodies come in. It's unhappy with this line because the problem with this line is that it can generate an error, basically. So for instance, if we were trying to send stuff across a network and the network wasn't available, it would time out and it would give an error. If the disk was full and you were trying to write the file out locally, it has the potential for giving an error. So there's all sorts of reasons why there's error conditions for that thing. And the Java way of dealing with those error conditions is to turn around and do what's known as a try catch. And so this thing actually ends up looking like that. Okay, and I'm just going to wrap this thing inside the try block and get it to generate the catch for me if I'm lucky. I'll get there eventually. And I'll add a bunch bunch of stuff there, and not sure, I think that's just a legacy beast. And we'll just do source format and see what happens here. Oops. One more time. There we go. It's a little better. Okay, so there's a couple of things that happened there in this weird business. Since this thing can generate an error, the way that you deal with the errors is, rather than having the thing return a result code, which is probably what you're used to, oh, it failed to do it right, and then check to see if the right was successful. The sort of the Java way of doing things is to surround this thing in what's known as a try block. And the try block basically says if any of the stuff in here produces an error, then we're just going to basically generate a stack trace.
Doesn't a try block have that catch?
Well, if you want to do the catch, then we'll do that. And when it gives an error, I'll generate the other option. It would look something like that. Okay? This is probably the more immediate form, so that's not such a bad idea anyway. So what a try catch block does is it says try to do this. If it succeeds, then continue on and do this. If it fails, so it's sort of like an else, then do that stuff instead. Okay? And in this case, catching the error means print out a stack trace saying, oops, something really bad happened, and what we'd probably do is exit the program at this point, but I'm not going to put the exit in there because there's other stuff I want to do. Okay? The other thing that's happened recently with Java is that normally what would happen if you had an error at this point is the most reasonable thing that you're probably going to do is close the file, because there's no use leaving it open, and there's only a certain number of open files that you can have. And traditionally what had to happen is you actually had to explicitly write the code to say, please close the file for me when I'm done with it. In the modern version of try catch, which has sort of got this embedded sort of equals thing in here, it turns out that it will automatically close files for you when it's done. And so you don't have to do that anymore, so you won't see a file.close in there like you would in the sort of the traditional way of doing this.
Is it possible that you could open the buffered writer successfully, but then write unsuccessfully?
Yeah, this thing will handle the whole works. So it's handling both the failure of the open call, and it's also going to handle the failure of the write, all by this one catch block, because anything that's inside here that fails for whatever reason is going to get caught by that thing.
Okay, so if the thing in the brackets fails, then it goes to the catch.
If anything from here to here fails,
Okay.
it's going to do whatever's in the catch.
Yeah.
And so it becomes a way of, instead of having to do a check every time you do something one at a time, you can just go, okay, if anything within this block fails, then let's take some error action. Because if the file fails to open, or if you fail to write stuff out, it's still basically the same idea. Oh, I'm going to have to take some exceptional action. You can also split this thing out. Instead of catching this generic thing, you can actually catch individual things. So you could have a second catch here that said, oh, one catch for if the file fails to open, do this, a different catch for if it fails to write. Okay? So you can have split them out into individual conditions, or you can just have one basic condition, which is what I've done.
So why do you want to separate the try into the two different parts where you've got the brackets and then you've got the slot? Why do you want to separate it like that instead of just having a block?
This is the thing, the opening statement. This is the thing that's actually going to open the file. So it's got to be in there. And then this is the stuff that actually does something with the file.
You couldn't have it all just...
It has to be like that. That's just the style that they use. Okay? The interesting thing about this is that the whole point for me showing you this is that this piece of code is basically boilerplate, in the sense that You're always going to make a string for the file name. You're always going to call this paths.get thing. You're always going to open up a buffered writer to write out whatever text file you're going to do. The only thing that's going to change is the string pieces that you grab out from the object or whatever you've got that you want to write out. Okay? And so you can basically take this sample and steal it now to use as the template to write any sort of code that you want that's going to output stuff to a file. Right now this just does one line though at the moment. Okay? So let's just see what happens for doing one line. We'll run the thing and oh, didn't produce any output, but apparently it might have written out a file somewhere. Where do you think the file's hiding? Same place as where? It's probably the same place as the compiled file is where you would expect, in the same directory. And if you think of these things as being folders, which they actually are on the file system, someplace in the SRC folder I would expect to see that thing, but I don't. Okay? And what may have happened here is Eclipse may not have actually seen that the file got left on the file system. And so I think it's F5 if I remember right, or refresh. Someplace in one of these options there's a refresh, which I can never remember where it is. Don't see it there. Deselect filters, yada yada yada. Can't find it. Maybe there's another refresh up here. Hides in some silly place.
Here's a refresh under file.
Under file, missed it. There we are. It was F5. Oh look, you do the refresh and it goes and updates its view of the file system, and there it is. Eclipse is just a basic text editor, so you can always open the file and see what's in it, and there's Fred Flintstone's been written out. Okay, so that's writing out one. If we wanted to write out a bunch of them, the way that I would do it is I would change this thing to say while, let's see if I can get this right, for student who in all students, we'll just convert that like that, oops, wrong place, do all of that sort of stuff, and I'm just going to get rid of the original who that was just one student. Okay, so move the who into a loop, just do a quick source format. Okay, so this is now I threw, instead of just doing one student, I basically threw a loop around it to say now let's do all of the students instead. So notice there's that little standard technique I'm using. If I can just use it to get for one, then I can probably find a way to throw a loop around it and get it to work for a bunch of them. Okay, and run this version of the thing, and it does some output, and so we'll go crack open my file now that we can see it, and we'll see what's in it. Oh, it says, oh, it's out of sync, so it's checking the date on the file. Hit F5, and there's all of the contents written out. Okay? So you now have the ability to take any Java class that we've made, basically, call its toString, or pick out the fields you want out of the file using the getter, and turn around and blast a whole list of them, or just a single object, out into a text file so that you can transfer it to someplace later. Okay? That's probably a good place to stop for the day. Where we're headed with this is next time around on Monday, we're going to figure out how to go back the other way. So how to take a text file and transfer it back and reconstitute it into Java objects. Once we've done a text file, we're going to turn around and say, well, text files are sort of boring. Let's try writing out an object file instead. So in binary, to save some space, as just another way. And it turns out that there's a really, really convenient way in Java to do whole bunches. You can write out basically the list all at once and have it write out everything underneath. So we'll look at that as a convenience mechanism. And then the last thing we'll do is we'll look at writing out XML files, because XML files are sort of the standard for being able to transfer data from one program to another, right? So find some way to at least be able to get the data out of our objects into some place where you could use it in some other thing like a Python program or whatever. Okay, that's where we're headed. And with that, we're done.